The task in this example is to determine the minimum of a function f of x, which is 1 minus e to the minus x on 2 logarithm of x on 5 over the interval for x between 2 and 10. Now in this function, log, as in always in this course, is the logarithm, the natural logarithm to the base e. And the task is to find the minimum to within an error of no more than a half, so that's an interval of length 1. Now here we've got the graph drawn. Normally we wouldn't know this, and our task is to find on this interval from 2 to 10 that the minimum lies here. So use the dichotomous search in MATLAB or Octave, and I'm going to use Octave. So start that up, and the first thing we have to do is to define the function f, and an easy way to do it here for such a simple one-line function is to say f is equal to at parentheses x, and then whatever I now type is the function f. So the expression is 1 minus x of minus x over 2 times logarithm of x over 5. And I use dot times for the multiplication so that we could provide a vector of values of x and get a vector of function values back in one simple expression, as we will see. Right, first task is to divide the interval 2, 10 up into 4 pieces with 3 intermediary points. Now remember that in MATLAB and Octave, 2 colon 2 colon 10 denotes a vector 2, 4, 6, 8, 10, which is the desired vector of x values. So to find out what f is on those points, we just go f 2 colon 2 colon 10 and find out their values are as follows. Now the dichotomous search and other such point searches, the rule is that out of the minimum of these values, the minimiser is on either side of the subintervals on either side of the smallest one of them. Here this is the smallest function value, and so the minimiser has to lie in the interval from here to here, and that corresponds to the x value 4 and the x value 8. So the next iteration of the dichotomous search is to halve the length from 2 to 1 and evaluate the function at the points 4, 5, 6, 7 and 8, which we get at by f of 4 colon 1 colon 8. Okay, so now the function values are as follows here. We find out the smallest value, which is this one. No, it's not, it's this one. I have to be a bit more careful. This corresponds to the x value of 7, and the subintervals on either side go from 6 to 8. So we know the minimum lies somewhere between here and there. Right, so we now want to go from 6 steps, half of the previous step, namely 0.5 now, to 8 and find out what the function values are there. And out of these function values, the smallest one is that. It's just a tad smaller than this one. So we know that the minimum lies in between 6 and 7. And the midpoint of that interval is 6.5. So otherwise, the minimiser is x is 6.5 plus or minus 0.5. That's the answer to the problem.